I am discussing the hydroformylation reaction or oxo process. First of all, what is hydroformylation reaction? With the addition of H2 and CO to the CC double bond of olefin in presence of rhodium or cobalt catalyst, then a aldehyde is formed. This reaction is known as hydroformylation reaction or oxo process. Here we have seen that two types of product is obtained. One is linear product or straight line chain product and another is branch chain product. In hydroformylation reaction, linear product is formed predominantly than that of the branch chain product. Now we have seen that what is the mechanism for the hydroformylation reaction. In hydroformylation reaction, we have used the catalyst of the cobalt, which is CO2 CSIRNET, which is act as a catalyst precursor. That means this species generated the active catalyst. Firstly, CO2 CSIRNET reacts with H2 to form HCO CSIRNET. This species is follow 18 electrons rule, and this is the active catalyst. This catalyst liberated the one CO molecule to form HCO3, and it is the 16 electron species. This species can participate the catalytic cycle for the hydroformylation reaction process. Now, with the addition of olefin, for example, RCH double bond CH2, then this type of complex is obtained, and this complex follows the 18 electrons rule. In this step, the migratory insertion takes place to the COH bond to form RCH2CH2CO, that means cobalt COTR, and it follow the 16 electrons rule. Then with the addition of CO molecule, then the complex RCH2CH2CO COTR is obtained, and it can follow the 18 electrons rule. In this step, the CO insertion takes place and the product is formed RCH2CH2CO. The CO insertion takes place, CO3H. And nextly, with the addition of H2, the oxidative addition reaction takes place. Here cobalt is the +1 state, but in this here the cobalt is the +3 state, and it can follow the 18 electrons rule. And the final step, reductive elimination takes place. That means RCH2CH2CO and OH this is the eliminated, and this is the linear chain product is eliminated by the help of reductive elimination reaction, and the active catalyst is the generated. Now we have discussed the monitoring the product ratio. In hydroformylation reaction, we have seen that the linear product is formed predominantly than that of the branch chain product. Now we have used the different type of catalyst, and we have seen that the different proportion ratio of linear and branch chain product. When we have used this catalyst HCO, that means this catalyst is a cobalt catalyst, then the proportion ratio of linear and branch chain product is 4:1. When we have used the another catalyst of the cobalt HCO3 PBU3 tertiary butyl phosphine, that is substitute of one CO group, then the linear product is ratio increases, and the ratio is 7:1. And when we have used the modified catalyst of the rhodium, that is HRHCO PPH3 whole twice, then the product proportion ratio of linear and branch product is 20:1. This data indicates that with presence of bulky ligand, the linear product is formed predominantly than branch product. This is because of the steric count. Now a question is arise: what is the disadvantage of HCO whole 4 in hydroformylation reaction? Now the disadvantage of HCO whole 4 in hydroformylation reaction. Now the disadvantage. This is very important of the disadvantage. The disadvantage of HCO whole 4 is the first point. HCO whole 4 is volatile. The first point, HCO whole 4 is volatile. That's why the product is contaminated by this catalyst. The second point, the reaction is carried out with olefin to HCO whole 4 at high temperature and high pressure. The reaction is carried out with olefin to HCO whole 4 at a high temperature and high pressure. And third point, 50% alkene lost through hydrogenation process. 50% alkene lost through hydrogenation by the use of this type of catalyst. And fourth point, very often branch product is predominantly formed than linear chain product. Branch product is formed predominantly linear chain product. That's why in advance we have used for the hydroformylation reaction, we have used the catalyst HRHCO PPH3 whole twice. Such type of problem is avoided by the use of this type of catalyst. Thank you.